IP or Internet Protocol. What is the IP? How we can use the IP? First, let me talk about the IP. IP is the abbreviation of the Internet Protocol. Okay, what is the protocol? Okay, what is the protocol and what is the difference of the protocol with software? We have two terms, software, okay, and then protocol. When you say we have a software, for example, we have Word as a software in our PCs, this means that this is a program that is working locally. This is a local program, okay? But when you say we have a protocol, for example, IP or HTTP, okay, this means that we have a program that is working between two or more systems. For example, between a PC and a web server. You know that we are using the HTTP for sending and receiving the web page, okay? This is the, for example, web server, and we are using the HTTP between the PC and web server for transforming the web page, okay? Now we can better use the protocol. Protocol is a software that we can use this software for transporting, for example, communicating between two systems or more than two systems, 4 systems, 5 systems, but not a local for example program. But the software is a local program. Look at here, Word is a software. Word program is a software, and you can use it locally without any communication with the other systems. But when you say protocol, this means that you have a for example program that you can use this program for communicating between some systems, for example 2, 3 or more than systems. For example, we have many protocols: HTTP, FTP, TFTP, Telnet, SSH, and other protocols, and also IP. IP is a protocol. This means that we are using the IP for communicating between systems. Okay, maybe you say no, IP is the, for example, this is the IP 192.168.1.1. I say that no, this is not IP, this is IP address. Okay, I will talk about the IP address, and this is so important for us, but you should, okay, you should know that we have two terms. That the first term is IP, means Internet Protocol. That this is a protocol. We use it for example, addressing and routing. I will talk about both of these concepts, addressing and routing. But IP has a component, we call it IP address. This means that when you use the IP address, okay, or IP, this for example address, this is one of the components of this protocol. Okay, you will learn about the IP, means the Internet Protocol, in this class, and after that also you will learn about the one of the components of this IP. We call it IP address. Because of that, until now, when you use the, for example, 192.168.1.1, you use the IP address, not the IP. But briefly, maybe you say this is IP, but this is IP address. Okay, let me to talk about the protocol. Until now, we learn about the difference between the protocol and software. Software vs, okay, protocol. This is the first things that we learn in this course. Okay, after that, now I'm going to talk about the protocol in this course, in the CCNA course, because we are talking about the communication between the systems. We need to know, we need to learn about the protocols, not software. Here we don't have any local software, we have only protocols. Many protocols exist, for example HTTP, for example IP, for example Telnet or DNS or DHCP, and some other protocols. You will learn about some of these protocols in this class, and also other protocols in the future class, CCNP or other classes. Okay, because of that, now we know that we will talk about the protocols in this course. Okay, we have many type of protocols. Okay, let me to talk about the protocol. What is the protocol? Yes, you know that protocol is a program that we can use it for communication between two or more systems. It's okay. But let me to give you one example, okay, to better understanding the function of the protocol. Look at this picture. In this picture, we have two men, okay? Here is the person one, and this is the person two, okay? Person one says hi, and person two says hi, and person one says got the time, and person two gives the time. Okay, this is the communication between two persons. Okay, after that, here we have a common language. The language is English. Because of that, because both of them are using the English language, they can understand the, for example, concepts of the communication. They can use the words of the English for talking with each other, and they can understand the communications. Okay. Assume that one of them is using the English and another, for example, is using the Arabic. This means that the person one cannot understand Arabic and the person two cannot understand the English. Because of that, they can't, okay, talk with each other, and this is a problem. Why? Because they are working two languages, okay, two different languages. They are using two different languages, and this is a problem. This means that if you want to communicate between two persons, you need a same language between these two persons, for example, English or some other languages, okay? Because of that, here we have a rule. That rule is the protocol. The protocol to communicating between two persons in this example is English language. The same language, the same rules, the same words, the same concepts between these two persons should be available to give them the ability to transfer the information to each other. Exactly the same things is happening between the computers. Look at here. Here we have a computer 1 and also computer 2. Assume that computer 1 needs to receive one web page from the computer 2. Okay, we need the same language between these two systems to communicating information, and also after that receiving the information, for example, a web page from the PC2. Assume that here we are using the HTTP. You know that, as I mentioned before, HTTP is a protocol, is a language that we can use it for sending and receiving data, okay, or web pages. For example, here we have the HTTP language, and also here we have the HTTP language. The PC1 says or request a TCP connection request. Don't worry about the detail. What is the TCP connection? You will learn about this, but assume that this is the first message. We call it a TCP connection request, then TCP connection reply. After some communication, this is the home page of the, for example, this site. This home page now is sending to the PC1. Okay, let me to write here. For example, here we have PC1. PC1 have the HTTP, and also we have PC2. PC2 also has HTTP. Okay, PC1 says the PC2, hey, please give me, okay, the web page of a special site, for example, the get message. And after that, okay, the PC2 should send the home page, okay, of the, for example, website to the PC1. Here we have some details. I'm not going to talk about the details because it is not our goal for to understanding the HTTP message in this time. Only I'm going to say that if you want to communicate between two systems for any reason, for example, receiving one web page, for example, receiving one file, or any other communication, sending email, receiving email, or other type of communication, we need the same language between the systems, and this language is the protocol. We have many protocols in our networks. For example, HTTP. HTTP is using for the communicating of the, for example, websites, web pages between the PCs. But if you want to send a file from PC1 to PC2, okay, you need to use another protocol. For example, we have a protocol, we call it FTP or file transfer protocol. Don't worry about the detail here. is not a place for talking about the detail of protocols. Only we need to know the general concept of the protocols. For example, we have another protocol, we call it Telnet. Telnet is a protocol that we can use it for sending commands for configuration from one device to another device. Okay, this means that we have many types of protocols, and each protocol, okay, can use for a special for example usage. For example, HTTP for sending and receiving the web page, FTP for sending and receiving files, Telnet is for sending and receiving, for example, configuration or some other functions. Very good. Until now, we learned about two concepts. The first concept is the difference between the software and protocol, and now we know that we need to talk about the protocols in the CCNA course. After that, we learn about the protocol and its, for example, definition. Protocol is the same language between two systems for a special usage. Also, we learn about some of the protocols in the network world, and finally we compare the protocol in real world, okay, where this is the for example same language between two person, and also we learn about the protocol between two pieces. Now we can better understand the concept of protocol. Very good. Now it's time to talk about one of the protocols that is the topic of this video, the IP. Okay, IP is a protocol or internet protocol. This is the abbreviation of the internet protocol. In many cases, we don't use the internet protocol. We say only IP. First, what is the IP? Why we need to talk about the IP, okay? Why the IP is the one of the most famous protocols in the network? I'm sure that you heard about the IP. Maybe you didn't understand about the detail of IP before this course, but I'm sure that you saw and also you use the IP in many for example cases, in many features, but maybe you didn't know about the detail of the IP. In this course, we will use the IP in many scenarios, in many examples. Because of that, the first thing I'm going to talk about that in this course is the IP or the internet protocol. First, let me to say that why we need to learn about the IP, what is the usage of IP, and why we need to learn the IP. You know that in today's networks, okay, for communicating between the PCs, for example, PC1 and PC2, okay, we are using some special rules or some special protocols. We call all of them TCP/IP, okay. Let me talk about the TCP/IP. You will learn about the TCP/IP in this course. Because of that, don't worry about the detail. But let me to say that here in the network, okay, we have many protocols for communicating between the two PC or more than two PC. This means that for communication between the PCs, we need some components. For example, we need HTTP, we need TCP, we need UDP, we need Ethernet. Okay, we need other protocols. You will learn about all of them in this course, and also in the other courses in the network, CCNA, CCNP, CCIE. Okay, all of these protocols, okay, with each other completely are calling the TCP/IP. Okay, TCP/IP is the protocol stack. Protocol stack means the stack of protocols. Here we have a stack of protocols that we can use them for different types of communication between the pieces. Maybe in some cases you don't use HTTP because you don't need to send web pages from PC1 to PC2, or you are using another protocol, FTP for example. But all of these protocols completely are called the TCP/IP. Because of that, we are learning the TCP/IP, because in these stacks of protocols, we have two most important protocols, the TCP and IP. We call this stack of protocols the TCP/IP. Okay, this means that we have, for example, 100 protocols in TCP/IP, but IP and TCP are the most famous of these protocols. Because of that, we call this all of these protocols TCP/IP. You will learn about this. Don't worry, and you should know that you need to learn networks step by step. Because of that, in each steps, maybe you learn some topic, okay, some information, but also you don't understand some of the topics. You can write that topics, and in the future, in this course or in other courses, you will learn about all of these features. Because of that, until now, you know that we have a networks in today's, okay, we call these networks TCP IP networks, because we are using the rules of the TCP IP, we are using the protocols of the TCP IP in these networks. And in this TCP IP, for example, network, we have two most important protocol. The first is TCP and the second is IP. Because of that, we call it TCP IP. Okay, and now because we are using the TCP IP rules in our networks, one of the most famous protocol is IP, and we are using the because of that we are talking about the IP. Now you know that why we need to talk about the IP or internet protocol, because this is the protocol of the addressing and also routing in TCP IP, and because our networks are TCP IP networks, we need to learn these protocols. The IP or internet protocol has two functions: addressing and also routing. What is the addressing? What is the routing? In this video, I'm going to talk about the addressing, but in this course, you will learn, okay, about the routing with, for example, many examples, many concepts. Because of that, don't worry about the routing. Here, I'm going only to talk about the addressing of the IP, addressing function of the IP, okay? But about the routing, we will learn in this course, not in this video, okay? Okay, very good. Let me to review again. Here, you know that the protocol function. Also, you know that we are using the TCP IP networks today's. And in TCP IP, we have one important protocol, we call it IP, not IP address. IP address is one of the components of the IP. Because of that, we will talk about the IP, and also IP has two functions. First, addressing. Second, the for example, routing. You know that every protocol in TCP IP has some function. Some of them using for sending or receiving traffic. Some of them is using for example, encapsulating the traffic. But here we are talking about the IP, one of the protocols of the TCP IP. Okay, and after that, IP has two main function: addressing and routing. Here I'm going to talk about the addressing. Now you can better understand what is the for example function of this video. This video is about the IP addressing. Very good. Starting about the IP addressing, you know that one of the function of the IP, one of the important function of the IP is addressing. Okay, and also about the addressing, we are using the special type of address for every and each device in the network. We call it IP address. Okay, you know that if you have for example 3 person 1, person 2, okay, and then person 3, you for communicating between these 3 persons, you need to give these persons one name. For example, the person 1's name is Arash, the person's 2's name is John, and the person's 3's name is Ellen. Okay, because of that, when I want to for example, send the traffic or talk with the person 2, I should say, hey, John. And after that, we can send the information. Or if I want to send information to Ellen, to person 3, I need to say that, hey, Ellen, hey, Ellen, for example, today is Sunday. Because of that, we need a special name, a special and unique name. One of the a specification of the address, one of the specification of names in the real world is the uniqueness. If you use same name on between the person 1, person 2, and person 3, for example, I'm using the same name Arash between these 3 persons, we can't use these names. Because of that, one of the, for example, a specification criteria of the address is the uniqueness. Look at here, assume that we have PC1 and also PC2 PC3, for example, PC1, PC2, and PC3. Because these three PCs are working in the TCP IP networks, we need to give them one special address. We call it IP. For example, we need to give the one IP address to the PC1, okay, IP address to PC1, and also IP address to PC2, and also another IP address to PC3, okay. The first criteria about this IP address, such as the real world, is the uniqueness. These IP addresses should be unique. If you are using the same IP address between three PCs or two PCs, they cannot communicate with each other. Let me to say that about the IP addressing, about the uniqueness of the IP addressing in the between the PCs, we can use many type of address, but in IP address we are using a 32 bits address. This means that each PC should have a 32 bits address. The 32 bits means 32 binary digit, okay, binary digit. You know that binary digits means 0 or 1. This means that each and every PC or any other host in the networks should have one 32 bits IP address. Let me to write one of them here. For example, this is only one example, 10101010 bit. Again, for example, quad 0, quad 1. Again, for example, quad 1, quad 0. This is only one example. And then 10000, then 1111. This is the IP address. Why? Because here, as you can see, we have a 32 bits. Assume that for PC2, I'm using this IP address. Only the last bit is changed to 0. And for the PC3, okay, I'm using this IP address. As you can see here, we have three addresses for PCs, and these addresses are not same with each other. This means that all of these addresses, all of these three addresses are unique. This is the same criteria that we need, the uniqueness of the IP address. Okay, first let me to talk about this uniqueness and how we can use this IP address. After that, I will give you another important criteria about the IP address, okay? Beside of the uniqueness, we need another criteria for every and each IP address. But let me first to talk about this IP address. Until now, we learned that the IP address, or briefly IP, okay, IP address or briefly IP, has 32 bits. This is a rule, okay? Maybe you say that why we need to use 32 bits? Why we can't use 20 bits? Okay. If you create your stack, for example, your networks model, maybe you are using one type of address that has only 20 bits, 20 bits. It's okay. But in TCP IP, okay, we are using the IP with the 32 bits. Before starting the conversation about the IP address and this address, let me to emphasize that TCP IP, okay, has two versions. Maybe you know about this, the version 4, and in the recent days, the version 6. In this time, I'm going to talk about only the version 4. Version 2, version 4 has some differences with version 6. We will talk about the version 6. Let me to write here, look at here. TCP IP has two versions, version 4 and version 6. TCP IP version 6. In version 4, we are using IPv4, and in version 6, we are using IPv6 for addressing and routing. IPv4 address, the addresses of the IPv4 protocol, has 32 bits, but the IPv6, okay, address, the address of the IPv6 protocol has 128 bits. I will talk about the IPv6 in this course, but not in this video. Because of that, after this time, each time that I say IP address, I mean the IPv4 address, not IPv6 address. IPv4 address, or briefly IP address, has 32 bits. Now we need to talk about the IP address. First, we should know about the IP address. After that, we can talk about the other functions of the IP. Let me to review that what we learned until now. Only we learned that in this course we will talk about the protocols. After that we learned about that we need to talk about the IP because our networks are TCP IP networks. Because of that we need to talk about the IP. IP has two functions. The first is addressing, and now we are using the addressing function. We are talking about the addressing, not about the second function, that is the routing. Here I'm going to talk about only the addressing. About the addressing, okay, we learned that IPv4 or IP address, okay, has 32 bits. Now I'm going to talk about these 32 bits. Also we have one example. This is one example that we can use this example for better understanding the concepts of the IPv4 address. This is so important topic in this course because in all of the scenarios that you will saw in this course, you should use the IP address. Because of that, it's important to learning this function, these concepts exactly as is, and after that you can use this address for all of the scenarios of this course. Okay, let me to start with this 32 bits. You know that every and each system in a network should has this 32 bits, and it's okay. But as you can see here, we have 32 bits 01, and this is a little hard for working with this. For example, address. Assume that you have for example, 100 PCs, PC1 to PC100, okay? And you need to address all of these PCs, PC1 to PC100, 100 PCs. This is very difficult to addressing these 100 PCs, okay, for example, with this 32-bit IP address. Because of that, we are using a conversion for easier usage of the, for example, addressing, IP addressing. Let me to talk about this. You know that in the real world, in the, for example, in the worlds that we are living at, we are using the decimal basis, okay? Decimals means all of the numbers are in base of 10, okay? Base of 10. Let me to give you one example. For example, when you say 156, okay, this means that you are using this value 1 multiplied to 100 plus 5 multiplied to for example 10, and also the 6 multiply the 1. This is the 156, okay? And if I write this for example parameters in the base of 10, I can say that 1 multiply 10 to the power of 2, okay? After that 10 to the power of 2. After that we have 5 multiply again 10 to the power of 1, 10 to the power of 1, and after that for example 6 multiply 10 to power of for example 0. As you can see here, we have a value 156. We are using it in the real world. For example, you can say $156, okay? And this means that you say, you talk about the 1 multiply 100, 5 multiply 10, 6 multiply 1, okay? And this is equal with the 1 multiply 10 to the power of 2, 5 multiply to 10 power of 1, and plus 6 multiply 10 to power of 0, okay? As you can see, we are using the powers of the for example 10. This is the first, this is the second, and this is the third. Because of that, we can say that we are using the binary, the decimal basis in the real world. Let me to give you another example. For example, let me here, I'm using this value 1234, okay? This means that, let me to write here 1 multiply 1000, and then 2 multiply 100, and then 3 multiply for example 10, okay? And after that 4 multiply 1. This is the for example, this is equal with this value. After that, let me to copy this function here. First, we have the 1 multiply, okay, 1 multiply 10 to the power of 3, okay, and then after that we have 2 multiply 10 to power of 2, and then 3 multiply 10 to power of 1, and finally 4 10 to power of 0. Okay, this means that again when we say 1234 we are using the basis of 10. Look at here, this is the first, this is the second, and also this is the third, and also this is the fourth. Okay, this means that in the real world we are using the decimal. This is the decimal. Okay, and the decimal is the easiest method for us for using in the normal communication or normal numbers in the real world. This is the selected basis that we are using, decimal. But in the computer world we are using another basis, binary. Okay, in decimal, as you know, in decimal value, let me to write here, in decimal value we are using this number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These values, okay, are the values, are the numbers that we can use in decimal, okay, in decimal word. But here we have another word, another basis of the IP of the addressing. We call it binary. In binary we have only 0 and 1. And when you say that I am using the binary basis, this means that you are talking about the basis of the 2, okay, 2 to the power of something. Let me to give you one example for better understanding. Assume that we have 156 in the base of 10. You know that this is the base of 10. Here we can use the parentheses, and after that we have an annex. Here this means that 156 with the annex of 10. Now the question is that how you can convert this value, okay, to the binary, okay, and binary is the base of 2. This is the binary. When you say binary, means I am using the base of 2. You need to write this value in the power of 2. What is the power of 2? Let me to review this for you. 2 to the power of 0, okay, equal 1. 2 to the power of, for example, 1 equal 2. Or 2 to the power of 2 is equal 4. 2 to the power of 3 is equal to the 8. You know it. 2 to the power of, for example, 4 equal to 16. 2 to the power of 5 equal to 32. Okay, 2 power of 5 equal to 32. Then 2 to the power of 6 equal 64. 2 to power of 7 equal to 128, and so on. Okay, how you can write the 156 in the power of 2? Okay, for example, we can say the 156 equal to the 128 means a 2 to power of 7. Okay, we don't use 2 to the power of 6 because if you add this value to the 128 you have a bigger value than the 156. But if you use the 2 to the power of 5, 32, totally you will have 160. Because of that, again, I'm not going to use this value, but we can use this value. 128 plus 16 equal is 144. Okay, again I can add the 8, 152 is the total. Okay, and after that we have a 4. Let me to add this value to each other. 128 plus 16 equals to 144. Okay, plus 8, 152, plus 4, 156. This means that if you want to use the binary values for creating the 156, you can use 1, okay, 1, 2 to the power of 7. Okay, let me to write here 1 multiply, I can use here 1 multiply 2 to the power of 7. Okay, this is the first value, and you know that we don't want to the power of 6 to power of 6. Because of that, let me to use 0 to the power multiply to the power of 6. And then also, as you saw, I didn't use 32 because of that. 0 to the power of 5 but I use the power of 4. Because of that, we need 1 multiplied to the power of 4, and also I use to the power of 3. Because of that, we need 1 multiplied to the power of 3, and also I use to the power of 2. Because of that, we need 1 multiplied to the power of 2. I didn't use 2 to the power of 1. Because of that, let me to use 0, 2 to the power of 1. Okay, and after that I didn't use the 2 power of 0. Because of that, let me to use 0, 2 to the power of 0. That's it. Okay, now this is the binary, for example, values of the 156. When you know that when we are using the decimal, we use these values, okay, for the decimal value 156, 156, also 1234, and these are the factors of the power of tens. The factor of power of tens is 1, 5, 6. Here is 1, 2, 3, 4. Okay, here also we need to use the factors of the power of 2s. For example, when you want to write the power of 2, here we have the 1, the first factor, and also and the next is 0. After that, the next is 0, then 1, then 1, then 1, 0, 0. Okay, this is the binary value of the 156. Look at here, 1 multiplied to the power of 7, 0 multiplied to power of 6, 0 to the multiplied to 2 power of 5. Okay, again 1 multiplied to the power of 4, 1 multiplied to 2 power of 3, and 1 plus 1 multiplied to the power of 2, and 0 multiplied to the power of 1, and 0 multiplied to the power of 0. This is the binary value if you use the factors. Here I use the factors. Here we have 8 bits, 1 0 1 1 1 1. As you can see here, we are using only the 1 and 0 because of that. This is binary. When you say that I'm using the binary basis, this means that you are using only the 0 and 1 in your number. Also, after that, you are using the factors of the power of 2. Let me to give you another example. These examples are important for us, but before that, look at here, decimal to binary conversion. A base exponent 2 to power of 7 is equal to the 128 to the power of 6, equal to the 64, as I mentioned before, 2 to power of 5, 32 to the power of 4, 16 to the power of 3, 8 to the power of 2, 4 to the power of 1, 2 and 2 to power of 0 is 1. And here we can see the conversion of 35. Let me to use the conversion of 35 here. Now we can easily calculate the 35. You know that in 35, okay, we don't have for example 128. Because of that, let me to use 0. This is the factor. And after that, we don't use the 2 to power of 6, 0. We have only 1 to the power of 5 means 32. Now we have only 3 value, because if you for example subtract the 32 from 35, we have only 3. We don't need 16, we don't need 8, we don't need 4, but we need 1 2 to power of 1, and also 1 to power of 0. Let me to add this value to each other. Here we have 32, also we have 2, and here we have 1. If you add these values to each other, now you have 35. This means that the equivalent of the 35 in the power of 10 is 0 0 1 0 0 0 1 1, okay, to the power of 2. Okay, this is the conversions of the bases. This is so important that you can do this function. Maybe in first scenarios this is a little difficult for you, but after doing some examples, you can easily convert the binary to decimal or decimal to binary. I will give you another example to better understanding the conversion between the binary and decimal. This is the basis of this course. Because of that, you need to learn this function so good, and after that you will use it. Let me to give you some for example examples. First number is 255, okay? 255 in the power of 10 equivalent to which value in the power of 2? This is the first question, okay? Let me to calculate this 255 in the power of 10 to a value in the power of 2, but I'm not going to again writing all of the for example details of the previous scenario. I'm using only these values. 255 equal to the 128. It has 128. Now if you subtract the 255 the 128 from 255, we have the value of 127. In 127 we have 164. Okay, let me to subtract 64 from 127. The value is 63. Also after that we have 32. You know that we have 32, and if I subtract the 32 from 63, the result is 31. Okay, and because of that we can use again 116. Okay, and this means that if you want you can use 31 minus 16, and the equivalent is 15. Okay, and here we have also 8. Let me to write here 15 minus 8 equal to 7. Also we have 4. Okay, and if you use 7 minus 4, the result is 3. Because of that we have 2, and then 3 minus 2 equal to 1, and because of that we have 1. This is the 255. I created 255 with the factors of the power of 2. Let me to write here for you 1 multiply, okay, 2 to the power of for example 7. Okay, and after that let me to copy this. Okay, this is the 1 multiply 2 to the power of 7, and after that a plus. Let me write here. After that I correct them. Look at here. Then 1 to multiply 2 to the power of 6, 1 multiply to the power of 5, 1 multiply to the power of 4, for example, 1 multiply to the power of 3, 1 multiply to the power of 2, and also 1 multiply to the power of 1. Okay, and after that 1 multiply to the power of 0. Okay, 128, 64, 32, 16, 8, 4, 2, and 1. Okay, look at here. Because of that, when you say 255, you in binary you need to say 1. Okay, again 1, again 1, again 1, again 1, after that 1 and 1 and 1. Okay, and this is the equivalent in the decimal, in the binary 1 1 1 1 8 1 quad 1 quad 1. Okay, this is the equivalent of the 255 in the binary, and this means that the biggest value that you can create with 8 bits is 255, and the lowest value with 8 bits is 0. Look at here. Assume that here we have the 0 in the base of 10. Okay, means decimal. If anybody, okay, says that this is the equal with which value in the binary, you can say quad 0 quad 0. Okay, because you know that if we use the factors of each of the to the power of, for example, 7 or 6 or 5, the 0, finally we have the 0 in decimal. This means that with 8 bits, okay, x quad x, again quad x, you can create a value between 8 zeros, okay, and to the 8 1. Okay, let me to write here 8 1. The lowest value is the 0, and the highest value in decimal is 255, and other combinations are a value finally results in a value between the 0 and 255. For example, if you want to create 256, you need 9 bits, not 8 bits. Okay, this is the first thing that you should know. Also, this is the decimal, okay, decimal to binary conversion. This means that if you have one, for example, one value in decimal, you can convert it to binary. How we can convert the binary to decimal? It's so easy. You can use the reverse function. For example, if I give you this value in the binary 10101010, that's it. Okay, how we can convert it to the for example, decimal? Look at here, this is the binary value, this is the binary value, and after that I'm going to find the decimal equivalent. How we can convert this value? So easy. 1 in decimal equal to 128. You know that this means 1 multiplied to the power of 7. After that we have 0 multiplied to the power of 6. Let me to write here. If you want, I can copy this value here, and after that we have 1 to the power of 7. We have 0 to the power of 6. Okay, we have 1 multiplied to the power of 5. We have 0 multiplied to power of 4. We have 1 again multiplied to the power of 3. We have 0 multiplied to the power of 2. We have 1 multiplied to the power of 1, and finally 0 multiplied to the power of 0. That's it. It's so easy. Let me to calculate the result. 128. This is the 128. Okay, after that 32 plus 0 plus 32, okay, plus 32, and after that plus 0 again. This is the 0, and after that plus 8, and then for example plus 0, and then plus look at here, 8 0 then 1. Okay, this means that we are using the 2 and then finally 0. That's it. Look at here, 128, 32, 8, okay, and then 2. That's it. Let me to add this value to each other. 160, 168, and 170. That's it. This means that this value is equivalent to the 170 in the basis of the for example 10. So easy. You should do this conversion with the, for example, these parameters, but in your mind. And it's so easy. After some examples, it will be easy to you. In the first days, in the first practice, it is difficult. For everybody, it is difficult. Okay, don't worry about that. But after some time of, for example, practicing, this will be easy for you. Look at here. If anybody give this value to me, I don't use this, for example, formula, this huge formula. I use this values. I add this value in my mind. For example, if I say this, for example, binary value, we can calculate this formula with in our mind. 128 plus 32, 160 plus 8, 168 plus 2, 170. That's it. Okay, this is so easy and so straightforward. For the only things that you should know about the binary to conversion or binary to decimal conversion or decimal to binary conversion is the power of 2. That's it. 2 to the power of 7, to the power of 6, to the power of 5, and finally to the power of 0. Okay, after that you can use these values to calculate easily the for example the equivalent of the decimal or binary. Also, let me to say that it is not important for this course, but let me to say that now you can easily convert any value from to other powers. For example, a power of 7, power of 6. It's not important for this course, but let me to give you one example. For example, we have a value. The value is 150. Okay, and this is a value in the decimal. Okay, I'm going to convert this decimal value to a value in base of, for example, 7. This is only is an example. Okay, 150 in power of 10 should be converted to a value in power of 7. First, let me to write here 7 to the power of 0 equal to 1, 7 to the power of 1 equal to 7, 7 to the power of, for example, 2 is 49. You know that in the 150, we need to use the power of 7. The 7 to power of 3 is, for example, larger than 150. Because of that, I'm not going to use it. But 7 to the power of 2, if we use 3 times this value, 3 multiply 49, this is equal to the 100, okay, 47, 3, 40, 120, 3, 9, 127, the equal is 147. After that, we need to add 1, for example, 7, 147 plus 7 equal to 154. This is larger than 150. Because of that, we need 0 times of the 7. And after that, we need 3 times of the, for example, 1 means 3 multiply 1 equal to 3. This means that this value 150 in power of 10 equal to the 3, okay, multiply 7 to the power of, for example, 2 plus 0, again multiply 7 to the power of 1. And after that, for example, we can say again 3, okay, multiply 7 to the power of 0, for example. And finally, we have 147 plus 0 plus 3, okay, and the result is 150. This means that the 150 in power of 10 equal to the 303 in the power of, for example, 7. This is so easy. You can for example, practice many values from power of 10 to the power of 7, power of 6, power of 5, or other powers. But we need to only learn about the conversion from the decimal to binary, and also binary to decimal. In the computer networks, we are using only decimal to binary and also binary to decimal. In some cases, some special cases, we are using hexadecimal. Okay, hexadecimal means the base is 16. Okay, we are talking about the power of 16. I will talk about that, but for now, let me, or hex, we call it hex. Okay, but for now, let me to only talking about the decimal to binary. After, for example, some scenarios, we will learn about the hexadecimal. Very good. Let me to review what we did until now, okay, about the IP addressing. You know that we are talking about the IP addressing, IPv4 addressing, okay, and until now we learned about the IP address is an 32-bit value, okay. 32-bit means 32-bit binary digit. Let me to write here, for example, quad x. This means that 8 bits. After that, we can copy these 8 bits again, 1 time, 2 time, 3 time. Now we have 32 bits. This is the address in TCP IP networks. In TCP IP networks, TCP IPv4 networks, every host means every system has one IP address. We call it host, okay? Or for example, such as the PC, such as the switch, such as the router, or other devices has one IP address, minimum one IP address. Maybe some devices has more than one IP address, but every device needs one address, one unique IP address for communicating with each other. And this IP address has 32 bits length, okay? Now, the question is that working with these 32 bits is difficult. How we can use these 32 bits, okay, with for example, easier method? The solution is conversion. Let me to talk, or translation. Let me talk about this. Look at here. You know that a man is, for example, using decimal and it's easier to us. But the computer is using the binary and it's easier to the computer that is using the binary. We can use a translation between these two values. Look at here, decimal, okay, to binary translation. This means that when we are configuring, when we are verifying, when we are using the addressing in the, for example, computer networks, we can configure the values with decimal value, but this OS or operating system can convert the values to binary for the, for example, computers, for the networks. And also when a binary value is received from the networks, the OS operating system can convert the value to decimal for the, for example, administrator. You know that administrator is using the decimal, but PC is using the, for example, binary values. Administrator is the manager of the networks, okay? And here, the administrator configure the decimal, and also the OS operating system can convert the values to binary, and because of that, the PC and administrator can communicate with each other easily. Okay, let me to talk about this conversion in this time. Until now, we know that the IP address has 32 bits, and these 32 bits only contain 0 and 1. Why? Because this is a binary value. In binary, we have only 0 and 1. How we can convert this binary value to a decimal value? We have some rules. The first rule is we need to divide these 32 bits into 4 parts. Let me to show you. This is the 32 bits. Okay, I'm going to divide these 32 bits to 4 parts. We need to divide 4 parts with 8 bits in each part. Look at here. This is the first 8 bit. We need to divide each 8 bits with each other. This is the second 8 bit, and also here we have the third 8 bits, as you can see. Now we have 4 8 bits, and after that we need to use one dot value between each 8 bits. Look at here, dot, and after that, okay, let me to use here again another dot. This is the for example, dot between these 2 8 bits, and finally again one dot. Now we have 4 8 bits, okay, with separating with each other with a dot. We call each 8 bit one octet or octet. In some cases, maybe you see the byte. You know that each 8 bit is a byte, but in most cases we are using the octet or octet, okay, byte. If you want, you can say octet or byte. Octet is better, okay? This is the octet 1. Let me to write here. This is the octet 1, okay, the first octet. And then this is the second octet. This is the third octet. And this is the fourth octet. Now, we have a 4 octets value. Only I divided these 32 bits into 4 parts, with each part with, for example, 8 bit or 1 octet. That's it. And also after that, I use one dot, okay, between each 8 bits. Now we have a value we can convert each octet to a decimal value. You learn about how we can convert the binary to the decimal. Let me to give you one example. For example, here in the previous part of for example, this video, we use this IP address. Let me to convert this IP address to the decimal. Look at here. This is the IP address in binary, IP address, and this is the IP address. As you can see here, first we have only 32 bits. Let me to add one dot between these two 8 bits or octets. Also here we have another octet. Okay, now we can convert easily these 4 8 parts, these 4 8 bits to the decimal. First, starting from the octet 1, let me to copy it here. Now you know that we can for example, calculate the equivalence of the decimal easily. Here we have 128. This is the 1, and also 1 0. And after that, okay, here we have, for example, 1 0. After that, we have 32. This is the 32, as you learned before. After that, we have 0. After that, for example, we have 16. After that, we have again 0. And then look at here, 128, 0, 32, okay? After that, 0. This is 1. This means 8, okay? And after that, 0. And after that, 2. And after that, 0. That's it. This is the equivalent to the decimal. 128 plus 32 is equal to 160, okay? Plus 8, 168, plus 2, 170. This is the first octet. The second octet, let me to use this value. Again, we need to convert it to the decimal. Here we have 0 plus 0 plus 0 plus 0. Then the equivalence of this value in the decimal is 8. Okay. After that, let me to write here. This is the, for example, 8. After that, we have 1, 4, 1, 2, 1, 1. That's it. 8 plus 4 is equal to the 12, then 14, then 15. This is 15. That's it. And after that, we have another value, quad 1, quad 0. Let me to convert it. Here, we have 128 plus 64 plus 32 plus 16. And then 0, 0, 0, 0. That's it. Okay, 128 plus 64 equal to the 192 plus 32, 224 plus 16, 240. Okay, this is equivalent to the 240. After that, we have another value. This is this value. Look at here. As you can see here, we have 128 plus for example, 0 plus 0 plus 0. After that, 8, then 4, then 2, then, for example, 1 equal to the 128 plus 8 equal to the 136. Okay. And then 140, 142, 143. That's it. Now we can write this value with a decimal equivalent 170. Okay, then dot 15, dot 214, after that 143. You know that here we have only the values, we can have only the values between the 0 to 255. Why? Because here we have 8 bits. Okay, 0 to 255, 0 to 255, again 0 to 255, finally 0 to 255. This means that one IP address in the decimal only can has the for example values in each octet between the 0 to 255. This is the value equivalent to this IP address. Okay, and as you can see here, we are using decimal values, and also beside of decimal we are using the dots. Okay, because of that we call this a method of presentation of the IP address dotted. Okay, dotted decimal notation, dotted decimal notation, or DDN. Maybe in some for example documents you see the DDN presentation, DDN notation. What is the DDN? Dotted decimal notation. One IP address that is converted to the decimal value and also separated with dot. Okay, this is the dotted decimal notation. In most cases, the administrator or admin, briefly, okay, uses the DDN value or dotted decimal notation. For example, administrator should configure 170.15.240.143 in a PC. Okay, in OS, the administrator configured this value, but the OS should convert this value to this value. Okay, let me to show you without dot, and gives this value to the PC. This means that the OS can convert the dotted decimal notation to binary, and also the binary to the dotted decimal notation. And because of that, administrator easily can use the for example assignment of the IP address in dotted decimal notation, and also the PC can use its binary format. Because of that, in most cases, in almost all cases, you will see only the DDN value in IPv4. Okay, we have about the IPv4 address. Okay, we have a value between 0000 quad 0, because this is the minimum value, to 255, 255, 255, 255. This is the biggest IP address, and this is the lowest IP address. Okay, and all of the other addresses are residing between these two values. I will talk about them. I will talk about the specification or detail of the other IP addressing. But let me to say, as a result of this, for example, video, that until now we learned about the TCP IP. Let me to review here. We learned about the protocol first, After that, we learned about that the TCP/IP is the protocol stack that we are using in our networks. In TCP/IP, we have one protocol for addressing. We call it IP, or Internet Protocol. IP also is used for routing. I will talk about the routing in future videos, but for now, only we are talking about the IP addressing. After that, we learn about the IP addressing, and we know that the IP address is an address in binary format with 32 bits length, okay? And after that, now we can convert this binary IPv4 address to the decimal value. We call it DDN, or dotted decimal notation. In most cases, we are using the DDN when we are assigning IP address to PC. For example, in this course, you will see that in some cases, administrator, for example, me, okay, I will configure the IP address 192.168, for example, 101 to one PC, okay, or one interface in the, for example, router or switch or some other devices. Because of that, in most cases, you don't configure the binary IP address on the, for example, PCs or interfaces. But actually, this is the OS's function that should convert the IP address that you assign in decimal value to binary for the, for example, communication between the system. And this is so important that we should understand that the real IP address, the real format that is used in the communication between the systems in the, for example, networks is binary, but we don't use binary. We need only to, for example, understand the conversion between binary and decimal, and after that we can use only the, for example, IP addressing in dotted decimal notation. Okay, very good. For this video, it's sufficient to know this information. Now you need to review all of the information in this video. Don't forget, if you want to be a master in network about the CCNA, okay, you need to first know about the fundamentals. After that, you can configure many scenarios, many networks, include switches, routers, or other devices. Don't worry about the for example, other features, other advanced features in this course. You will learn all of them. But for now, it's so important to learning everything correctly. Step by step, you need to grow, okay? Because of that, first, until now, you need to learn about the conversion of the, for example, binary to decimal and decimal to binary. And finally, you will convert the binary IP address to the decimal IP address. And when you reach to this ability, okay, you can come with me to the next video. In the next video, again, I'm going to talk about the IP address, but with more advanced feature. For example, in the next video, we will learn how we can use the IP address. What is the classes of IP address, okay? What is the special part of the IP address? What is the routing function in the IP address? In the next video, I will talk about the routing, okay, in IP address briefly. And after that, I will talk about the classes of the IP address, okay? And after that, I will talk about the component of the IP address. For example, network ID. What is the network ID? Network identifier. What is the host ID, okay? Most important part of the for next video is the network ID and host ID. It's so important to understand these features. But for now, only you need to review the features, the concepts in this video. After that, please come with me to the next video. Again, we will talk about the IP or Internet Protocol, and we will go one step more, for example, to learning about the networks. I'm sure that if you study this course and this video with the, for example, all of the practices, all of the concepts, and for example, other features that you will learn in this course, finally, after this course, you will be a master in CCNA. You can pass the exam of the CCNA, you can pass the interviews about the CCNA, and after that, you will be ready for learning the more advanced features in the CCNP.